Hi guys, introduction to scientific notation, which is kind of cool stuff. You'll see throughout your lives in science more than math actually. So if you ever take any chemistry, it'll be part of things you do. Physics too, to some extent, and then just in general, it's actually a pretty good thing to know if you're into math or not. So basically, it's based on this. If I said that 10 to the 5, we kind of looked at this sort of thing. Or 10 to the 5 is 10 times 10 times 10 times 10 times 10. But the other thing is, it ends up being like this. So if you go, there's 5 here, right? And there's 5 tens, and then what ends up happening is there's 1, 2, 3, 4, 5 zeros, right? You can put a comma there. You're not supposed to, but I'm going to do that in this a little bit because it's easier to see. So anyway, 10 to the 5 looks like this, and scientific notation is a way to kind of write like a short form when things aren't that important. So for example, if you're talking about the number of molecules somewhere, and the number of molecules turn out to be something like this, okay, you do a big calculation. Well, there's two things to this. One, that number's enormous. I don't even know what it is. Two, is this number really right? Like, if we ever make a calculation that is that big, is that correct? Are we off by one? Like, could that be the number of molecules, up or down, right? Or even maybe a couple hundred? So, what we kind of do is, a lot of times, just to write that in short form, what we do is we kind of base it on the fact that 10 to the 5 is going to have 5 digits after the first number, right? So, you think of it this way, it's kind of like 1 and then 5 digits after it. What we do is we do the same thing here. So, if I had this giant number here, just to round, what I would do is I would say, look, why don't we just talk about this number right here? So let me change that, 6. And you're going to say, instead of just writing this number, which is huge, and we could even have bigger numbers, much bigger numbers, right? But instead of writing that out and trying to talk about that, what we can do is we can say, look, that's 7.7, or 6.7, sorry, about 6.7 times 10 to the, and then what we do is we figure out how many numbers are after the 6. So we go, there's 1 digit, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we write it like that. So we go 6.7 times 10 to the 11, okay? So that's how we write scientific notation, and it's used as a short form. You can add, sometimes we do something like this, 6.7 times 10 to 11, and what that means is, if you had 6.7 and you multiply by 10 to the 11, well, that'd be 1 with 11 zeros after it. Or you're going to move the decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. Now, we kind of do that here. And if you look at that, that's 11 spots. And we kind of just ignore all this stuff here. And we kind of round it to this number here, which is like, I don't know, 67 billion or whatever it is. Okay? That's how we write scientific notation. It's not precise, but we're looking at situations where things are not necessarily precise. So we don't really need to know the exact number here, but we like to know a general idea about how big the number is, right? So the key is that we know that there's a 6 and then maybe a 7 and then 11 digits after it. Okay? So if I said to you, I have a bunch of money and I have this much money ish, okay? And these are all zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. What I can do is I can write this as 3 times 10 to the 10. Okay, that's a short way to do that. So that's scientific notation, real quick. It just, you take a number, and if I had something like this, let's say I had 1.62 times 10 to the 4. If you want to write it, expand this, what you do is you go 1.62 times 10 to the 4, you move this over once, twice, 3 times, 4 times, and then that's where we end up. And we just throw zeros in here. Anytime there's kind of a blank, we put zeros in there, and the number ends up being 16,200. Okay, so let's try this one on your own. I'll give you a second here. I keep writing 6, so let's try 8.3 times 10 to the 7. Okay, give you a second to write that out. You would go 8, and then you would go 3, and then you would go 1, 2, 3, 4, 5, 6. So there are 7 numbers after the 8, after the decimal. Okay, so there's 8 in the decimal, and there's 7 numbers after that. We know one of them is a 3, and then the rest are zeros. Sometimes we have more numbers. So let's say we had something like this, 8.367. Then you would go like this, and then you would write zeros after it. Turn it into something like that. It also works in the negative direction. So if I had something like this, 1.2 times 10 to the negative 5, what that means is let's move the decimal over to the left now. Okay, we're going to move that over 5 spots to the left. So that'll be 1, 2, 3, 4, 5. The decimal ends up here, and everywhere we have a blank, we put a 0. So that turns out to be 0 or 0.0000012, and usually we throw a 0 in front of the whole thing also. So let's work backwards here. Let's change our color up. Let's work backwards, and let's say we had this. And we wanted to write this in scientific notation. What you would do is you would say, okay, I got to move that over once, twice, 3, 4, 5, 6 to get here. So it'd be 7.9 times 10 to the 6. But because I'm moving to the right, it's going to be negative. Okay, so 7.9 times 10 to the 6. Work backwards, 1, 2, and if you did that, you'd end up with 0.000. 0. I forgot how many zeros. 5 zeros. 7, 9. Okay, that's scientific notation in a nutshell. All right, hope you enjoyed.